3:02 p.m. in the afternoon, and I am having a Google Hangout on air, my first in several months. Please be understanding if this is not actually technically working. I've tried to share links with Facebook. I'm not sure that actually worked, but no matter, this Hangout will be archived on YouTube if you don't catch it live. My stated objective in this Hangout is to demonstrate how to draw three-point perspective in Photoshop just the way that I do. By the way, I am the author of Perspective and Extreme Perspective and the upcoming Perspective in Action. So I pretty much know what I'm doing when it comes to perspective, if not to Hangouts. Anyway, without any further ado, let's go to Photoshop. That's not Photoshop. That is Photoshop. So I hope everybody can see this. So here's a demonstration of three-point perspective, what I hope to do with this, the kind of drawing in three-point perspective. But I am going to completely erase all this and start over. So the first thing that I do is set up a top line, a top horizon, and I'm going to make sure that it is exactly horizontal at zero degrees. Now I'm going to add another line to the left and another line to the right to complete a triangle. So that is 3 horizons, and they represent, and the points of the triangle represent 3 vanishing points: left, right, and down, which is also called the nadir. So now the next step here is I'm going to draw a line from the bottom vanishing point crossing the top horizon, and it's going to be exactly perpendicular, 90 degrees. Yeah, that's pretty good. Now I'm going to add another line. What I'm going to try to do is establish the center of vision for this perspective. And the center of vision is just the area that's closest to your eye, where you have the area of least distortion. So there's a lot of distortion as you get away from the center of vision, and less when you are at the center of vision. So I'm taking this line and I am cloning it. I'm copying it, and now I'm going to rotate it 90 degrees. So I'm basically creating a line that is perpendicular to that line of the triangle on the right. And I may need to expand it a little bit, but there. So now I have a point where that line crosses the other one. And that's enough to determine where my center of vision is. It's right there. And that's the area where you should concentrate your drawing when the diagram is finished. And let me just add another line here, passing through the center of vision, crossing the horizon on the left, because we'll use that line later. So now let me mark the vanishing points, just to be absolutely clear. These are the vanishing points. Now, it's not enough to know where the vanishing points are, because you want to be able to do accurate measurement going back in space. And for that, you need to divide space up into a grid. So in order to do that, you need to find diagonal vanishing points. And here's how I do it. I have another layer here, and I'm going to change the color to red. And what I'm going to do is, holding the shift key down, I'm using the elliptical window tool here, and I am creating a circle. I'm filling it with red. I'm going to make it a little bit transparent. And now I am going to put that circle onto the horizon. Try to match it up exactly where the horizon is exactly cutting it in half. I'm applying it. And I'm going to get rid of half of it. So what we wind up with is a semicircle. And the reason we've done this is that a semicircle that goes from one vanishing point to the other, any two lines, let me get another layer here. Any two lines from the vanishing points onto the edge of the circle will meet at 90 degrees at a right angle. So this line under the center of vision right there, that point on the semicircle, that will be a right angle. And this is important because we want basically a square in plan, or a right angle in plan, so that we can find the diagonal vanishing point. So the diagonal vanishing point will be at 45 degrees of that 90-degree angle on the horizon. And the way we find that is we take one of these lines and we rotate it. We rotate it. We rotate it so that it is 45 degrees from where it was. So that gives you the position of your diagonal vanishing point on the horizon. But you need to find 3 of them. So going back to this layer, get rid of that bit. Going back to this layer, let's take the circle, semicircle, and rotate it around so that it is aligned with the left horizon. This is a transverse horizon that is going from one of the vanishing points to the vanishing point, the down vanishing point of the nadir. And I am sizing it carefully so that we have it more or less accurate. So now again, I'm finding the spot, the line passing through the center of vision, and finding a spot on the semicircle. Let me just get rid of those lines and create some new lines. Once again, this is a 90-degree angle. And I will take one line of it I will take one line of it and rotate it 45 degrees. Put it back on that point. And now we found where that diagonal vanishing point is. Now I think we can get rid of this semicircle. We don't need that. And we don't need these lines anymore. Let's make the lines right again. So here's one line. Here's another line. And a third line. If you have two diagonal vanishing points established in a three-point perspective, you can find the third one by crossing two of them and then drawing another line through. So now we have all three vanishing points and all three diagonal vanishing points on all three horizons. This still may be confusing, but we'll start to fill the details in. So now let's make the line red again. Let's go back to this layer and start to divide the space up. What you're basically looking at, it may not be clear just yet, but you're looking at three walls or sides of a cube all meeting at a corner. So I'm dividing this space up into X's. I'll do this on one wall first to make it as clear as I can. But see here, this very distended looking quadrilateral is actually one wall of the cube, and I am creating divisions within it. So and they can be as They can be as small as you like. I think 4 by 4 is enough to give the idea. So now I'm going to do this again on the bottom square of the cube, or the floor. Using the lines that are already there. Let's see. And running through here. And here now you see, I hope you're not too confused by the other lines going to the vanishing point, but you have on the bottom, you have a 4 by 4 division, 16 squares. So I'm going to do this now for the left wall. And here I'm using a division that I've already made on the right wall, just continuing it over on the left wall. And here are divisions on the edge of the floor, and I just carry those up. And now I have it complete. It's probably not clear enough, so what I'm going to do is fade those lines. And in the background, I'm going to draw them in black. So first of all, here are the edges of the cube meeting at a corner. Now, here on the right wall are equal divisions dividing that space up into 4 by 4 squares. And likewise on the floor, and likewise on this wall. And you're seeing very extreme distortion, which is typical of three-point perspective, because three-point perspective, the vanishing points are very, very far out from your center of vision usually. Okay, so now I'm going to kind of fade the lines a little bit. And I think I'm going to delete this layer and delete this layer. Yeah, that should do it. So now I have a nice, reasonably faint, I'm going to add another layer, reasonably faint background to draw three-point perspective. And this spot here, let me try it again, that is the center of vision, which is close to the corner of that cube. Anyway, so now you can refer back to the vanishing point if you need to, but the lines that you have in the scene should generally give you an idea of the direction of lines. So you can start to fill in things. Now it's convenient to make the corner of the cube the corner of the room. You don't have to. You can extend things out. You can extend it out to here, make that the corner of the room, make that the edge. these square divisions can be whatever you want them to be. They can be 1 foot or 1 meter or 3 inches. It really doesn't matter. But what is nice is that they are consistent. So a square going in one direction will be the same measure as a square going on the other. A square on the wall is the same as a square on the floor. Let's include a little bit of the molding there. Maybe have a little line texture there. You can start to draw a window here. And maybe something outside it. You can put a rug on the floor, going that way. Have a picture on the wall. And what I haven't drawn is a person. He might be a little tall for that room, but might bump his head on that ceiling. Let's maybe do an end table. With a vase of flowers on it. Blah, blah, blah. Maybe a floor lamp. And this is all very loose and sloppy, but you can get a lot tighter, particularly if you want to go back to the vanishing point to give you exactly the direction that that line would go, for example. Or if you really want to get the molding accurate at the top of this room. Oh my goodness. It looks like that picture is already at the ceiling. So let's give it a little more room. There we go, something like that. And that should about do it. Anyway, and of course you can do this sort of thing also in Illustrator. I imagine you can do it in Manga Studio, but most people I know are working in Photoshop, so that's the method that I use. And thank you for your very kind attention. I'm going to have to find my way back to my window so that I can end this, and I'll be back in February.